We're going to be looking at a few applications of quadratic equations, and one of them is a distance rate time problem. So you have probably seen these in beginning algebra, but the formula is that distance is equal to rate times time. And we can also solve for the other variables. For example, solve for t by dividing both sides of the equation by r, or solve for r by dividing by t. So we're going to start with a problem. My husband and I have driven to Carlsbad, and my husband doesn't like the way I drive because he drives 11 miles per hour faster and he saves 1 hour on the trip. And the question is, based on this information, how fast is each of us traveling? So we're going to fill in what information we have and then use two columns to calculate a third column. So we'll start off with 330 miles. That's pretty straightforward. I drive 330 miles to get there, and my husband drives the same 330 miles for the return trip. So that's the first column that we'll fill. And then the second column says my husband drives 11 miles per hour faster and saves 1 hour. And we could construct algebraic expressions either involving rate or involving time. If we use rate, we would say x plus 11 to indicate 11 miles per hour faster. But if we use time, we might use t minus 1 to say saves an hour means 1 hour less. And the question is, which of those should we use? And I'm going to make my decision based on the question, how fast is each of us traveling? That how fast is asking for a rate, and so I want my variable to be expressed in the rate column. So I am going to use the 11 miles per hour faster to write two algebraic expressions. X plus 11 is the 11 miles an hour faster, but the implied other expression is going to be x. And because my husband drives faster, so the first row I put for myself, and for the second row I put for my husband, and my husband is driving faster, so his rate will be the x plus 11, and my rate will be the x. Next, what I want to do is construct an expression for time, and you can see from this formula, time is equal to distance divided by rate. So since I have two columns filled, I can use those two columns to fill the third column by doing a calculation. So we'll express time as distance divided by rate, which is 330 divided by x. And we can do the same thing for the second row by dividing distance by rate and getting the expression 330 divided by x plus 11. Next, I'm going to make use of the information that my husband saves 1 hour by putting together just a sort of generic equation regarding times. And so his time is going to be less than my time if he saves an hour. So I'm going to say that his time is equal to my time minus the 1 hour. And now I can use the times that I calculated in this column to put into this equation here. So putting the expressions in the equation, we see that his time is 330 divided by x plus 11, so we'll put that over here, is equal to my time, which I've written as 330 divided by x, minus 1. And this fractional equation has denominators of x plus 11 and x, and we'll need to multiply every term in this equation by the least common denominator, which is going to be the product of those two denominators. So we have three terms in this equation, and each one of those terms is going to be multiplied by the LCD, which is x times x plus 11. So we can now cancel the denominators for two of the terms, and the third term doesn't have a denominator, so we will have to keep all of those factors. But when we simplify on the left, we get 330 times x is equal to 330 times parentheses x plus 11, which gives us 330x plus 3,630. And then from the third term, a negative x times x is a negative x squared, and negative x times 11. We can simplify by subtracting off the 330x from both sides and essentially canceling. And then we want to rearrange this in descending order for our quadratic equation. So we end up with the equation negative x squared minus 11x plus 3630 is equal to 0. If we were going to factor this, we would want to factor out the negative sign in front of the x squared. But if we're using the quadratic formula, we can just as easily use a negative coefficient for a as for the other variables. So we can just plug in the values of a, b, and c to get our solution. So in the quadratic formula, negative 11 becomes positive, plus or minus the square root of 11 squared is 121, minus 4 times, now the a is a negative, so we've got negative 1, 3630, divided by 2 times negative 1, and we've got to watch our signs here. So simplifying some more, we see that the inside of this radical actually becomes a rational number. When you take the square root, it's 121. So we have our two solutions. One is by adding 11 plus 121, but divided by a negative 1 number gives us a negative 66. And the other is 11 minus 121 over the negative 2 gives us a positive 55. And this negative solution we will eliminate because we are talking about physical properties, and x is a rate. It's number of miles per hour. So there are a couple things to note. One is when we go back and interpret this, we've got that x is equal to 55, so that means that my rate or speed is 55 miles per hour. My husband's rate can be computed by plugging 55 in for x, and we get 66 miles an hour. A couple things from that. We notice that with our discarded solution, the negative 66, if we had added 11, we would have gotten the other number to be a negative 55. And so when we set up the equation is not accounting for the physical properties, whether the answers are allowed to be positive or negative. But again, we eliminate the negative ones when we interpret the problem. The second thing is that my husband really is the one who should be driving, and you don't want to get behind me on the freeway.